Alright, in this spell work, it's pretty easy here. You're given a function, and you have a table, and I have given you some x values. You have to find f of x. So what does that mean? Well, that means that if you have x values, you plug them into the function, and in this case, the x is the only thing in the denominator. So you're plugging these numbers into the denominator and figuring out what you get once you plug it in. So let me demonstrate here by doing a few of these. So if I plug in -2, because that's my first x value, to here, that means that I have 1 over -2. Now, just to make this easier for me to graph later, I'm going to have to graph these coordinate points. I'm going to change this to a decimal. So -1/2 is also -0.5. So I'm going to change them to decimals if they're fractions. So -0.5. Okay, the next one here, I'm plugging in -1, as you can see. So if I plug in -1 into this function, I get 1 over -1, which is -1 when I divide. So the next one here is -1. And then the next one, I have f of -0.5 divided by 1 over -0.5, which is, if you put this in your calculator, you should get -2. And so I get -2 here. And if I plug in this into my calculator, I get -4. However, this last one here, sorry, not the last one, this middle one here, if I plug in 0, let's take a look. So if I plug in 0, that means I have 0 in the denominator. We learned that when the denominator is 0, the overall value is undefined. So whenever the denominator is 0, it's undefined, because you can't divide by 0. So we call this undefined. So that's what I'm going to write here. In the next one, we are also plugging in 0.25, but this time it's positive. So if I were to plug this into the function, it's going to be the same answer as before, but only this time it's going to be a positive answer. So this is going to be 4. Next one needs to be a +2 then if I plug it in. And if you don't believe me, you can go ahead and plug it in and see if that's the case. If I plug in 1 into this denominator, I get +1. If I plug in 2, I get +0.5. And I have filled out my table here. And so these are coordinate points. I have the x and the y's. So I'm going to go ahead and plot them on a graph here in the next slide. Because I want to know what this function looks like. So that's why I'm picking x values to plug in so that I can plot a few points so I can get a good idea of what this graph or this function looks like on a graph. Okay, for this one here, on this slide, you don't need to rewrite this table that we filled out on the first slide. I just have it here because I needed to look at it while I plot the points. So you don't need to copy this part. So what I'm going to do is maybe first scale the axis and put some numbers down. So perhaps I'm going to make this 1, 2, and 3. Put 2 units of spacing because I got some decimal values. Because I have some decimal values for these x. So I'm going to make some room here. Do spacing here, -1, -2, -3. Okay, now I'm going to plot the points here. So I have -2 and -0.5 for my y value. Also, I forgot to mention, I'm going to keep the y-axis the same. So 1, 2, 3, 4, 5. Like this is still the same type of unit. I'm just going to not label. I don't really have to. So I have -2 down 0.5, which is right about here. Next one I have -1, -1, so that's going to be down here. Next is 0.5 negative, negative 2, which is going to be right here. And then I have 0.25 down 4. 0.25 down 4 is about right here. And then next, I got 0. But 0 is undefined, so that means that I don't have to plot for 0. So nothing's going to show up on the graph. And then I have 0.5, 4. So 0.5 is right here and then up 4. Next is 0.5 and then up 2. So 0.5 up 2 is right here. Next is 1, 1. So 1 up, 1 over. So right here. And last but not least, 2. And then up 0.5. So right about there. Okay, so we got our points. The next thing to do is to connect the dots. So we're going to go ahead and connect the dots here. And with this curve, when you curve it, you want to try to get really, really close to the, what is this called? The y-axis, but you don't want to touch it. And this curve is getting also really close to the x-axis, but it's not going to touch it. And this part here is going to get really close to the, notice how it's like curving like this. It's going to get really close to that y-axis, but not touch it. The same thing when it's going down this side, it's going to get really close to the x-axis and not touch it. So this is what the curve looks like. It kind of reminds me of a baseball, the threading, kind of caving both in. So, this shape here, excuse me, you can see that the curves are caving towards the axis and getting really close, but not touching it. Where have we heard this before, where the curve or the line is curving towards the axis or towards a line and not touching it? Well, that's asymptotes. So notice that down here, when it's curving towards the x-axis, and this side here is also curving towards the x-axis, we have a horizontal asymptote. Let me highlight that. So right here we have a horizontal asymptote, because in this case it's getting really close to this y-axis but not touching it. Remember, asymptotes you can't touch or cross. So we have a horizontal asymptote here when we look at our plots and our curves. We notice this horizontal asymptote. And then for our vertical asymptote, you might notice that the curve is getting really close to that y-axis, but not quite touching it. Like this side here is getting really, really close, and this side here is getting really, really close as it's pointing down. And it's gliding right against it, but it's not crossing it or touching it. And so we have some asymptotes. Now, if we have some asymptotes, it's going to affect our domain and range. But before we get there, let's label these asymptotes. So for this asymptote, because it's a horizontal asymptote, it cuts, horizontal asymptotes are represented by y's. Okay? The reason why is that any horizontal line will cut through the y-axis. Notice how it like horizontal cuts through the y-axis. So in this case, it's represented by y. For this one, it's cutting through y equals 0, right? 0 value for y. So in this case, this is y equals 0 for the horizontal asymptote. Whereas the vertical asymptote cuts through the x-axis. Notice when I go up and down, it cuts through the x-axis. And so that's why we're going to need an x here. And this vertical asymptote cuts through x equals 0. For the y-intercept here, that's when you plug in 0 for x, but notice we got undefined. So if we got undefined for the y-intercept, there is no y-intercept. Also, when you look at the graph here, the y-axis, we don't have any points where the curve crosses the y-axis. So you don't even see a y-intercept when you look at the graph. All right, next is, let's talk about the domain. So domain is represented by x values, right? So if domain represents x value, whereas range represents the y values, actually, let me do that in different colors here. Let's do that corresponding. So domain represents x values, whereas range represents y values. Well, for the domain, we always, if we're looking at the x values, we look left and right. So as this side of the curve is going to the left, it's approaching negative infinity, right? And this curve here, when it's pointing to the right, it's approaching positive infinity. But what's happening in between? Well, if we look, if you think of a tiny ant crawling on this curve, it's going to the right, and it's going, but then there is like this asymptote, and because we can't cross it, that means that in this case, this tiny ant's gonna fall. Think of this as like a ditch, the asymptote as a ditch. It falls in, and then it can't cross over. So asymptotes, because you can't cross over it, in this case, that x equals 0, we have an issue. But once you cross over it, you have no problems. So the x values here are all there except for x equals 0, because that's the one that causes the problem. So the domain is all real numbers except x. When it equals 0, it's the asymptote and it can't exist there. You can't touch it at x equals 0. So in this case, x cannot equal 0 for the domain, or else it has issues. Whereas the range, it's all real numbers. And so take a look here. The range here talks about the y values. So if you look at the y values here, if you're going down, right, this curve points down and approaches negative infinity, whereas it points up and is approaching positive infinity. Well, in this case, if you look at the curve, it's pointing down towards negative infinity, but if you go the other direction, it's going up, 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 up. So think of this tiny ant going up, and it's trying to go up, but then there is a horizontal asymptote in the way, so it can't cross it, right? So that's an issue at y equals 0. But if it hops over it, then the ant's okay, and it keeps going up, up, up. So it's like all the y values work except at y equals 0. So we're going to say all real numbers except when y is at 0. So we're going to say y cannot equal 0. This equal sign with the slash in it means that it can't equal whatever that number is. All right. So next we're going to try out some more problems, but I'm going to take this type of equation, a rational function, and we're going to add some shifts to it. So we're going to add things to the equation and see what type of shifts it would do to the graph. Okay, so here's my first example here. It kind of looks like the first problem, only there's a +2 here. Now, before we try to find the horizontal asymptote and the vertical asymptote by making a table and plotting points and seeing how the curves connect. But this time around, we're not going to make a table. Instead, we're going to figure out ways we can find the horizontal asymptote and vertical asymptote without it. So here's what you have to do to figure out the horizontal asymptote. So remember how the original horizontal asymptote was y equals 0? Well, in this case, notice that this is the same function, but there's a +2 here. That +2 is a type of shift. So if you have a +2, that means you have a vertical shift. So the graph is shifting up and down. Well, because it's a +2, it's going to be shifting up If it's a minus, it's shifting down. So in this case, the original y asymptote, horizontal asymptote, was y equals 0. But because this asymptote is at 2, or sorry, the shift is at 2, then the horizontal asymptote is going to go up 2. So 0 plus 2 is 2. So because the horizontal asymptote got shifted, it's going to go up 2. And then the vertical asymptote, what we can do to figure the vertical asymptote out is by figuring out what x makes the denominator 0. So when you look in this denominator here of the fraction, what does this x value need to be to make this denominator 0? Well, x has to be 0. If x was 0, that means that this denominator here is going to be undefined, and we don't like undefined values. Undefined values actually causes asymptotes, at least vertical asymptotes. So in this case, now when I look at this, I'm going to find the domain and range. Because once I have the asymptotes, I know the domain and range. So for domain, it's associated to the vertical asymptote. So when x equals 0, that means that the domain is all real numbers except when x equals 0. So x cannot equal 0. Whereas the range is going to be all real numbers for the y's except when y is at 2. So we're going to say y cannot equal 2. If I were to next plot this on the graph here, I'm going to graph these asymptotes first. So we have y equals 2. So I'm going to graph a horizontal asymptote at y equals 2. I'm going to make my dashed line here. And my vertical asymptote, I'm going to make my dashed line going down on x equals 0. So remember, asymptotes we cannot touch. So I'm going to do my best to avoid touching the asymptote. If you remember before, because the asymptote got shifted, everything else about the graphing is the same. So we graph in the right top corner and the left bottom corner. So when I make my graph here, I'm going to curve and get really close to that asymptote, but not quite touch it. So in a way, it kind of caves in. You get really close to the asymptote and do my best to not touch it. And then we have it. We have those caving in curves again, or that L-shaped type of curve, and you can think of this part here as a reflection of it. All right, so kind of to sum things up here, to find the horizontal asymptote, what you got to do is look for vertical shifts. So that means that if you see the fraction and on the side you see a plus or minus sign, that is a vertical shift next to the fraction. And if you want to know what the vertical asymptote is, you got to look in the denominator and figure out what x values causes the denominator to be 0 or undefined. All right, let's try a few more. All right, this one here, if you take a look at this fraction, next to it we don't have any shifts, right? So if there's no shifts or plus or minus signs on the side of the fraction, then the horizontal asymptote by default starts at y equals 0. Well, that also tells me that the range is going to be all real numbers except when y is at 0. So in this case, I'm going to put y cannot equal 0. The vertical asymptote is when we look in the denominator and figure out what does x need to be to make this denominator 0. Well, if x was equal to 3, right, 3 minus 3 equals 0. So in this case, the vertical asymptote is 3. And so that means our domain is all real numbers except when it is 3. So I'm going to say x is not equal to 3. So now that I have my asymptotes, I'm going to make my dash lines. So when x equals 3, we have a vertical asymptote, and when y equals 0, we have a vertical asymptote. And so when I draw my lines here, I'm going to try to get really close to that asymptote but not quite touch it, and I always start in that right upper corner and then left bottom corner. And there we have it. We have our asymptotes and our curve on the graph. Okay, so now we're on our third example. So here's our function. So when we take a look at this function, now I think we see a vertical shift, right? Here's our fraction. There's a +2 here. And again, this is going to have a vertical shift, and it's going up 2 units. So in this case, by default, it starts at y equals 0, but it's being shifted up 2. So this is going to be y equals 2. And so remember, the horizontal asymptote is associated with the range because the range talks about y values. So in this case, the range is all real numbers, but y cannot equal 2 because we have an asymptote there. And then for the domain, we need to look at, for the vertical asymptote, we need to look at the domain. So x is equal to 4. So what makes this denominator here 0? Well, when x is equal to 4, that means that this would cause the bottom or the denominator to be undefined. So if I make this 4 minus 4, notice when x is 4, I get 0, and that would be undefined. So x is equal to 4 for my vertical asymptote. So my domain is all real numbers except when x is equal to 4, because that causes the bottom or the denominator here to be 0. So now that I have my asymptotes, I'm going to plot my asymptotes with my dash lines. So x equals 4, so I have a vertical asymptote at 4, and I have a vertical asymptote at 2. So when I make my curve, start in the upper right-hand corner, and then the left bottom corner. And cave that in. Notice, if you guys haven't spotted this yet, notice that I tend to cave in towards where the cross of the asymptotes meet. So where the asymptotes cross each other. Notice how the curves cave in. So it might be helpful to see where that cross point is and then cave in your asymptote, your curve. Okay, so let's try one more out. And this is the problem when we deal with a negative sign here. So whenever you have a negative in the numerator, or sometimes it looks like this, sometimes you might have a problem. You have f of x equals negative 1 over, so the negative's like to the side instead. Anytime you see a negative in the numerator or to the side, something changes about the graph. So I'm just going to highlight that negative sign and talk about it later. But for the rest of the problem, it pretty much stays the same. So if I'm trying to find that horizontal asymptote, I want to look at if I have any shifts. So looking at this graph here, I have a -3. So by default, I have to shift down 3 units on the y. So we always start at y equals 0. If I'm shifting down, that means I have y equals -3. So my range is all real numbers except when y equals -3. Whereas the vertical asymptote, if you look in the denominator here, this x needs to be 1 for it to fail, right? For the denominator to be 0 or undefined, because 1 minus 1 is equal to 0. So x, when it equals 0, the domain is all real numbers except at x equals 1 because we have an asymptote. So if I were to draw these asymptotes here, we have -3 for y, so that's going to be down here. then x equals 1 for the asymptote. So at x equals 1, I'm going to draw a vertical asymptote. So this time, instead of drawing it where it's in the top right corner and the bottom left corner, because there's a minus sign, what happens is that this curve is going to switch its places. So now this bottom one is going to, or the left side is going to be on the top, caving in. So the left one is now in the top left corner. But I'm still going to do the same. I'm going to try to get close to that asymptote, but not quite touch it. And diagonal from that, in the right side, I'm going to be in the bottom of the coordinate. So bottom right. So notice how before it was this way, but now it's the opposite because there's a negative sign. So what negative signs do is that they make it, they reverse the location of the curves. So you do everything the same to find your horizontal and vertical asymptote. The only thing when you draw your curves, make sure you draw it in the left to be on the top right, the left to be in the up corner, the top corner, and the right to be on the bottom corner. And that's it for this journal. So hopefully this helps you with page 1 and page 2 of packet 13.